We need that torch over here now.
It's almost ready. Keep pressure on it.
Watch the sparks, watch the sparks.
Move the track closer.
Pour the fuel, let's go.
Check the tension on that bolt.
Keep the tension steady on the front cable.
Watch the boom! Watch the boom! More heat on the left side.
Got it. How long we got?
Not long. Keep working.
January 17th, 1945. The sun barely rises over a frost-bitten French countryside, gray mist clinging to the shattered trees along the roadside. Mud churns beneath the treads of abandoned Sherman tanks, their engines silent, stubbornly refusing to start. American soldiers sprint across frozen earth, lugging toolboxes, spare tracks, and fuel cans. The air is thick with the scent of diesel and smoke from a distant artillery barrage. Clang! Metal meets metal. Sparks fly as wrenches turn stubborn bolts. A mechanic wipes frost from his goggles, revealing eyes locked on a stalled tank. Nearby, a half-track rumbles up, its crew jumping down with cables and spare parts, moving with practiced urgency. Every second counts. The Germans are not far, and reconnaissance drones have spotted the activity. Across the field, hidden behind shattered hedgerows, German engineers stare in disbelief. They had assumed this battlefield would slow the Americans, leave their armored columns stranded. Yet here, under bitter cold and constant threat, small crews move like clockwork, repairing, refueling, restoring what should have been lost. In that moment, mobility becomes a weapon, and a new kind of war is quietly unfolding, one that few would notice, yet would shape the fate of armies. By early 1945, the Western Front had become a complex web of ice, mud, and steel. Following the successful D-Day landings in June 1944, Allied forces had pushed deep into France, driving German armies back across shattered towns and battered countryside. Mechanized warfare, once a novelty, had become the backbone of modern combat. Tanks, half-tracks, and trucks moved in relentless waves, supplying infantry and artillery, bridging gaps, and exploiting breakthroughs. Yet with each mile of advance came the same inescapable challenge. Machines broke down, engines seized in mud, tracks snapped under the weight of armored steel. A stalled tank could delay an entire column. A burned-out vehicle could block a road for hours. The United States Army recognized this vulnerability early. Unlike the Germans, who relied on static repair depots often far from the front, American forces developed mobile maintenance and recovery units. These were not simple repair teams. They were highly trained, strategically deployed, and equipped with specialized vehicles. Wheeled workshops, mobile cranes, and reinforced trucks stocked with spare engines, tracks, and tools. Their mission was singular: keep the Army moving no matter the conditions. Field manuals meticulously outlined procedures for vehicle recovery, improvisation under fire, and rapid deployment. Engineers and mechanics were trained not just in repair, but in anticipating failures before they immobilized the fleet. The innovation extended beyond tools and manuals. Logistics officers created rapid supply lines, including the famed Red Ball Express, a network of trucks moving essential fuel, ammunition, and spare parts at all hours, often through dangerous and unpaved routes. These supply arteries allowed repair crews to reach disabled vehicles deep in enemy territory within hours. In contrast, German maintenance units often operated at a disadvantage. Supply lines were stretched thin, fuel scarce, and spare parts limited. Repairs frequently required returning vehicles to central depots, far from the front lines, leaving tanks and armored cars idle for days. The difference was profound. An American armor division could strike, sustain damage, and recover almost as quickly as it had advanced. German forces, meanwhile, watched helplessly as their own defensive efforts were undermined not just by firepower, but by a level of logistical sophistication they had not anticipated. Reconnaissance officers sent reports of repair convoys moving with uncanny efficiency, noting that American crews seemed to anticipate every mechanical failure. Arriving before a vehicle could become a permanent obstacle. These reports sowed both frustration and disbelief among German engineers, who had prided themselves on technical skill, yet now confronted an adversary who had turned maintenance into a weapon. The human element of this system was as crucial as its machinery. Crews worked under bitter cold, mud sucking at boots, artillery fire echoing across the fields. Mechanics crouched beneath tanks, fingers numb, hands slick with grease, exchanging terse instructions shouted above the roar of engines. They improvised solutions, welding broken tracks, jury-rigging fuel lines, cannibalizing parts from one vehicle to keep another operational. Every successful repair allowed a Sherman or a half-track to rejoin the line, keeping offensive momentum alive. For the men on the battlefield, the speed of these crews was nothing short of miraculous. By January 1945, these innovations had been tested repeatedly during the Allied advance through France and into the Low Countries. In the Ardennes, during the Battle of the Bulge, mobile repair crews became lifelines, recovering tanks that had slipped into frozen ditches or been damaged in German counterattacks. Each recovery saved not only material but morale. Soldiers witnessing a battered tank claw its way back onto the road felt a renewed confidence, a tangible symbol that the Army could endure, adapt, and continue pressing forward. This environment of mechanical ingenuity and relentless movement created a new paradigm of warfare. The war was no longer decided solely by strategic bombing, infantry assaults, or armored thrusts. It was increasingly shaped by the ability to repair, recover, and redeploy at an unprecedented pace. And while frontline commanders directed attacks, the invisible work of mobile repair crews quietly dictated the operational tempo, often before the enemy even realized it. As German engineers observed from behind hedgerows and ruined villages, the speed and organization of American maintenance teams were unlike anything they had encountered. Stalled tanks were no longer dead weight. They became temporary setbacks, quickly erased by teams who operated with precision, determination, and ingenuity. The battlefield was evolving, and those who adapted fastest, even in silence and behind the lines, held a decisive advantage. By the winter of 1944 to 1945, the American advance across Western Europe had stretched across hundreds of miles, a chain of armored and mechanized units moving in relentless waves. Each mile brought new challenges. Snow-covered roads turned to ice, muddy fields swallowed vehicles whole, and shell-pocked towns created bottlenecks that threatened to halt progress. Yet for every stalled Sherman or disabled half-track, an American mobile repair crew was never far behind. These teams had become essential instruments of operational continuity, restoring vehicles in the field faster than the Germans could respond. One notable example came during the drive toward Aachen in October 1944. American armored columns, pushing into the German frontier, faced stiff resistance and treacherous terrain. Tanks bogged down in mud and frozen ditches could have delayed the entire offensive. But mobile repair crews, equipped with recovery cranes, spare tracks, and portable workshops, moved swiftly. Within hours, Immobilized tanks were dragged from the mud, repaired, and returned to the line. Artillery observers later noted that U.S. tanks seemed to rise from the earth, a remark that would be repeated in captured German intelligence reports. In some cases, vehicles that might have been counted as losses were restored so quickly that German forces had no opportunity to exploit the momentary advantage. Contrast this with the German approach. While German panzer divisions were formidable in combat, their maintenance system was rigid and centralized. Disabled tanks often had to be towed back to depots far from the front line. Spare parts were rationed, sometimes arriving weeks after a vehicle broke down. Frontline repair crews were fewer in number, less mobile, and often lacked the redundancy built into the U.S. system. When German engineers attempted field repairs, they faced shortages of essential components, harsh winter conditions, and constant pressure from advancing American forces. The difference in operational tempo was stark. Where the Americans could repair, redeploy, and continue an offensive in hours, the Germans might take days to recover a single armored vehicle. The innovation of mobile repair crews went hand in hand with logistical foresight. Red Ball Express convoys delivered fuel, ammunition, and spare parts along meticulously planned routes, often through contested or treacherous terrain. Trucks moved day and night, braving artillery fire and the threat of ambush to keep the frontline units operational. Mechanics and engineers were assigned to specific divisions and even specific tank battalions, creating familiarity with the vehicles they would encounter. Every truck, every tool, every spare track was accounted for, ensuring that a stranded vehicle was never truly abandoned. This combination of mobility, organization, and foresight allowed U.S. forces to maintain relentless pressure on German defenses. During the Battle of the Hürtgen Forest, for instance, tanks that had become trapped in the dense, shell-pocked woodland were often rescued by small repair detachments, preventing the slow attrition that might have otherwise favored the defenders. German reports from the front noted with growing frustration that Americans seemed able to restore combat power almost instantaneously, denying the Germans the opportunity to exploit any lapse in the advance. The cumulative effect was not just material, but psychological. German engineers and commanders, accustomed to using mechanical attrition as a delaying tactic, found themselves powerless against a system that erased the battlefield's obstacles. Soldiers who had once relied on immobilizing American tanks for strategic advantage now watched as these same tanks returned to the line, repaired and ready for combat. The efficiency and speed of these crews became a force multiplier, amplifying the effectiveness of every division, every company, every tank in the field. By the end of 1944, it was clear that the war in Western Europe had entered a new phase. Battles were no longer solely measured by troop movements or firepower. The capacity to repair, recover, and redeploy vehicles in the field had become an essential determinant of operational success. And while this work was largely invisible, occurring behind the lines or in frozen fields, its impact on the battlefield was unmistakable. The Germans, despite their own technical skill, were being outpaced in a war where mobility, and those who preserved it, had become the decisive advantage. For the men of the U.S. Army's mobile repair units, the battlefield was both workshop and frontline. Mechanics crouched beneath tanks in freezing mud, fingers numb, tools rattling against steel as engines, fuel lines, and tracks were coaxed back to life. Sweat froze on brows, goggles fogged, and the sound of artillery was never far away. Each repair carried a silent urgency. A stalled tank could halt an entire column, expose infantry to enemy fire, or give the Germans a fleeting advantage. Yet, amid the chaos, these crews operated with remarkable discipline. Soldiers recounted moments where a Sherman tank, its tracks ripped open by a mine, was lifted, repaired, and redeployed in less than an hour. Every wrench, turn, and improvisation became a race against time, with human skill and determination substituting for luck. The camaraderie within these crews was palpable. Mechanics shouted instructions over gunfire, sharing expertise learned in months of grueling training. For some, the work was grueling. For others, it was exhilarating, a chance to make a tangible difference when the outcome of the war seemed so vast and distant. In the eyes of German observers, these men seemed almost superhuman, capable of restoring death machines to life with relentless precision. The mobility of these repair crews altered the tactical calculus of battle. Commanders could press attacks with confidence, knowing that vehicles temporarily disabled by mud, mines, or enemy fire could be restored and returned to action. No longer did a knocked-out tank signify a lost opportunity. With rapid recovery, entire armored formations maintained momentum. In the Ardennes, during the winter counteroffensive, U.S. units relied on mobile maintenance to keep supply lines open and tanks operational in forested, hilly terrain. Roadblocks, destroyed bridges, or frozen rivers posed less of a strategic threat, as repair crews could drag, tow, or improvise solutions that kept the army moving. German forces, anticipating a slowed advance in these harsh conditions, were repeatedly frustrated by American persistence. Each operational success, every tank recovered under fire, translated directly into tactical advantage, allowing attacks to continue with minimal disruption and leaving the enemy scrambling to adjust. Technology underpinned every successful repair. Mobile repair units were equipped with specialized half-tracks converted into field workshops, carrying spare engines, tracks, fuel pumps, welding equipment, and an array of hand tools. Recovery vehicles with cranes and winches allowed crews to lift immobilized tanks from ditches or mud. In addition, trucks carried pre-assembled replacement modules for critical components, enabling entire sections of a tank or half-track to be swapped out in minutes. These innovations were not improvisational. They were carefully developed through training, engineering manuals, and battlefield experience. Mechanics knew which failures were most common under specific conditions: frozen oil, jammed transmissions, broken tracks, and prepared accordingly. Standardization across U.S. armored divisions meant that a spare track or engine for one Sherman could fit another without delay, further increasing efficiency. German engineers, observing this level of preparation and technological foresight, were stunned by how much battlefield mechanics could compensate for environmental and combat damage. The very concept of rapid, frontline restoration seemed alien to them, where repairs were traditionally centralized and slow. The effectiveness of mobile repair crews was not an accident. It was the result of meticulous planning and leadership. U.S. officers understood that an army marches on more than just bullets. It marches on fuel, spare parts, and the ability to keep its machines moving. Field commanders coordinated closely with logistics officers, ensuring that repair units were positioned strategically behind advancing lines, yet close enough to respond to breakdowns immediately. Prioritization was key. Commanders had to decide which vehicles were critical to the mission and which could wait. A Sherman leading an armored spearhead took precedence over a supply truck. Officers also trained mechanics for rapid decision-making under pressure, emphasizing improvisation when standard repairs were impossible. This empowerment of lower-ranking men to act decisively transformed small repair crews into high-impact units. The result was a force multiplier effect. Effective leadership enabled a few dozen mechanics to sustain the combat power of entire battalions, a principle that German commanders struggled to counter. For German engineers and commanders, American mobile repair teams were a revelation. Captured intelligence reports and post-war accounts reveal a mix of disbelief and frustration. German maintenance units were accustomed to static depots, centralized repairs, and ration parts. The concept of mechanics operating under fire, restoring heavy armored vehicles within hours, challenged their assumptions about battlefield attrition. Reconnaissance units frequently observed American crews dragging disabled tanks out of ditches or lifting burned-out vehicles onto flatbeds in near-impossible conditions. German officers recorded these instances with a sense of exasperation, noting that the Americans repair what we destroy, highlighting the psychological impact of this operational resilience. For many German soldiers, it was demoralizing to see an enemy unit seemingly shrug off mechanical failures that would have halted their own advance for days. The efficiency and speed of U.S. repair teams forced the Germans to reconsider not only tactics, but their entire approach to battlefield logistics. The presence of mobile repair crews had profound effects on morale. For American troops, the knowledge that disabled tanks and vehicles could be recovered almost immediately instilled confidence. Infantry and armored units pressed forward with less fear of immobilization or supply chain disruption. Witnessing a crew lift, weld, and restart a stalled Sherman under artillery fire became a tangible symbol of resilience, a reassurance that the Army could overcome obstacles through skill, teamwork, and ingenuity. Conversely, the Germans experienced a subtle but persistent psychological strain. Officers and engineers who had relied on the natural slowing of American forces due to mechanical attrition found themselves repeatedly surprised. Tanks that should have been left stranded were returned to combat, undermining defensive plans and contributing to a growing sense of helplessness. Morale among German maintenance personnel suffered. Their inability to match the mobility and efficiency of U.S. crews became a recurring theme in field reports. In many ways, the repair crews were not only restoring vehicles, they were reshaping the battlefield perception, turning logistical superiority into a weapon of psychological warfare. January 16, 1945. The frozen Ardennes forest lay shrouded in mist, its skeletal trees casting long shadows over roads scarred by shell craters and abandoned vehicles. The 3rd Armored Division of the U.S. Army was advancing cautiously, each tank and half-track a lifeline in the bitter cold. German forces had dug in, expecting the frozen terrain to halt American progress. Snow and mud had already immobilized dozens of vehicles overnight. The assault, like the forest itself, seemed impassable. Then the repair crews arrived. From the rear, trucks bristling with spare tracks, tools, and welding equipment rolled forward, headlights cutting through the gray morning. Mechanics leaped from the vehicles, each man moving with precise, rehearsed urgency. Wrenches struck metal, hydraulic jacks lifted tanks from icy ditches, and welders patched shattered tracks. Soldiers on the front line watched as machines that had appeared doomed returned to life, engines roaring, turrets swiveling, ready to rejoin the offensive. Time was measured in minutes. A Sherman that had been buried halfway into a roadside ditch was freed and rearmed in less than an hour. Across the same sector, a half-track carrying infantry ammunition stalled in mud. Within 20 minutes, it was lifted, repaired, and moving again. German reconnaissance spotted the flurry of activity and sent reports that conveyed disbelief. They repair under fire. They do not stop. Every vehicle lost is restored. The tactical effect was immediate. U.S. armored units, previously stalled by terrain and enemy resistance, resumed their advance, pressing into German defensive lines with renewed force. Infantry followed closely, supported by tanks that had been recovered in record time. German engineers and officers scrambled to respond, but their own repair units could not match the speed or coordination of the Americans. For every tank they disabled, another returned to the fight almost instantly. One particularly dramatic incident occurred near the village of Hansfeld. A Sherman, struck by artillery and buried in ice, seemed a lost cause. German troops began maneuvering to secure the kill and remove what they assumed was a permanent obstacle. Yet within 30 minutes, a mobile repair crew arrived. Using a combination of winches, jacks, and makeshift timber ramps, the men extracted the tank from the frozen ditch. Tracks were replaced on the spot, the engine roared to life, and the tank rejoined its platoon. The sight was recorded by a German officer in his report. The Americans recover what we destroy. We cannot anticipate their speed. Every repair, every reactivated vehicle had a multiplying effect on the battlefield. Commanders leveraged the restored tanks to reinforce breakthroughs, respond to flanking attacks, or push deeper into German-held territory. The repair crews, often unarmed or lightly equipped, became linchpins of the offensive. Their actions blurred the lines between combat and logistics, transforming the very nature of engagement. A single team of mechanics could dictate the pace of an entire division, a concept that German forces had yet to fully comprehend. By nightfall, the Ardennes sector bore the marks of this extraordinary efficiency. Rows of repaired tanks lined the roads, engines still warm from relentless use. American troops, exhausted yet emboldened, prepared for the next day's advance. German forces, meanwhile, reevaluated their assumptions about attrition and battlefield advantage. What they had considered a predictable delay, a tank immobilized by mud or artillery, was no longer a certainty. The war had shifted, subtly but decisively, toward those who could not only fight but repair, recover, and redeploy with unmatched speed. January 17, 1945. Dawn broke over the Ardennes, painting the frozen forest in pale gray. The U.S. 3rd Armored Division prepared for another push. The night had not been quiet. Artillery shells had struck at the perimeter, yet the tanks repaired the previous day now rumbled along the narrow roads, their engines steady, their crews alert. Each vehicle represented a calculated gamble won, not through firepower alone, but through the unseen labor of mobile repair crews who had defied terrain, weather, and enemy observation. German commanders were beginning to grasp the implications. Reports filtered back. Disabled Shermans and half-tracks recovered faster than their own forces could destroy them. Bridges that had been blown were circumvented or reinforced by repair teams. Immobilized vehicles rejoined columns before flank attacks could exploit their absence. For the Germans, the battlefield was no longer a predictable series of attrition points. It had become a living system, responsive, adaptive, and shockingly resilient. In one sector near the town of Monshaw, a battalion of American tanks had been stalled for hours by icy roads and German artillery. Mobile repair crews arrived under sporadic shell fire. Teams worked in tandem. Engineers lifting, mechanics welding, and drivers preparing vehicles for redeployment. Within 90 minutes, the stalled tanks were moving again. German artillery crews fired upon them, only to witness the tanks evade and advance, seemingly reborn. The speed and coordination disrupted German plans, forcing commanders to pull units back to prevent encirclement, effectively conceding the initiative. The psychological impact was profound. German engineers, accustomed to calculating enemy downtime based on mechanical failures, found their models obsolete. Every assumption about immobilization was rendered meaningless. Tanks and half-tracks that should have been out of the fight returned to action, undermining morale and strategic calculations. Officers wrote reports noting that the Americans operate as if time itself bends to their will, a reflection of both admiration and frustration. Meanwhile, American commanders leveraged the recovered vehicles immediately. Forward units pressed into villages and defensive positions with minimal delay, exploiting gaps that would have been closed if mechanical failures had been permanent. Infantry followed armored support with renewed confidence, aware that any disabled tank could soon be restored to the fight. Supply lines, reinforced by Red Ball Express convoys, ensured that fuel, ammunition, and spare parts flowed to the front continuously, creating a self-sustaining operational cycle. By mid-morning, the pace of advance accelerated. German forces, unable to match the speed of repair and redeployment, began to retreat under mounting pressure. Attempts to ambush isolated tanks failed repeatedly. Vehicles repaired and returned to combat neutralized threats that might otherwise have halted the offensive. The battlefield had become a contest not just of firepower, but of mechanical endurance and logistical precision. One German report captured the emerging reality. No matter how many we disable, they repair. Every hour we anticipate delay, we find only renewed movement. Their engineers and mechanics are as much a weapon as their tanks or artillery. The phrase would echo through post-war analyses, illustrating the turning point in the Ardennes and other sectors. The capacity to repair and redeploy rapidly had become a decisive factor in modern warfare. By the end of the day, the difference was undeniable. U.S. armored divisions held more ground than anticipated, their momentum preserved not just by tactical skill, but by a systematic approach to mechanical recovery. German units, meanwhile, were forced into defensive withdrawal, their attritional strategies thwarted by the efficiency of repair crews operating in the shadow of combat. The Ardennes, a battlefield of frozen mud, artillery, and fire, had quietly become a proving ground for an innovation that would define the closing months of the war. Mobility sustained through relentless repair. The decisive lesson was clear. Battles would no longer be decided solely by who fired first or moved fastest. They would increasingly hinge on who could maintain operational readiness, restore machines under fire, and leverage them back into combat. And on this frozen January morning, amidst the wreckage and smoke, it was the unseen hands of mobile repair crews that determined the pace, the momentum, and ultimately, the outcome of the engagement. By the end of January 17, 1945, the Ardennes sector bore the unmistakable mark of sustained American initiative. Tanks, half-tracks, and supply vehicles lined the roads, some bearing fresh repairs, others still en route from overnight recovery efforts. The advance of the 3rd Armored Division, initially slowed by treacherous frozen terrain and determined German resistance, had not only resumed, but exceeded expectations. The mobile repair crews had turned potential delays into opportunities, keeping armored thrusts continuous and enabling U.S. forces to exploit gaps in German lines before defensive positions could be reinforced. The operational impact was significant. Reports from division commanders indicated that nearly 60% of vehicles initially immobilized during the first day of the offensive were restored and returned to combat within hours. Entire battalions that might have faced temporary stagnation were instead redeployed at full strength. German reconnaissance, once confident that frozen roads and artillery fire would force attrition, now found American columns moving almost as if the battlefield were cooperative rather than hostile. The balance of initiative had shifted decisively toward the Americans, and the tactical consequences were immediate. German counterattacks faltered, supply routes were contested with greater intensity, and defensive positions became increasingly untenable. Materially, The difference between repair efficiency and attritional loss was stark. Whereas German forces often had to abandon disabled panzers and half-tracks due to fuel shortages or lack of spare parts, American recovery teams salvaged tanks that would have otherwise been counted as permanent losses. In many cases, vehicles that had been reported destroyed were repaired on-site and returned to frontline duty within a single operational cycle. One after-action report noted that our mechanical recovery teams restored nearly 3/4 of immobilized armor in less than 12 hours, a figure that contrasted sharply with German recovery operations, which could take several days for a single vehicle. Beyond numbers, the crew's actions carried a tangible psychological effect. Soldiers on the front line witnessed the impossible. Tanks rising from mud, half-tracks abandoned overnight returning to service, and engineers working under fire with disciplined urgency. For American troops, this reinforced confidence and operational morale. Infantry units trusted that armored support would remain available, even in adverse conditions. Commanders could plan more ambitious maneuvers, knowing that vehicle breakdowns would not dictate the pace of operations. German forces experienced the inverse effect. Reports captured in captured logs and post-war interviews reveal mounting frustration and disbelief. Engineers, accustomed to using mechanical failures as tactical advantages, found their calculations consistently invalidated. One German officer wrote, "Every delay we predict is erased. Our attritional strategies fail against an enemy who restores what we destroy." The efficiency of American mobile repair units forced a reevaluation of tactics and strategy, leaving German commanders reacting rather than dictating. This shift in initiative eroded confidence and contributed to incremental losses in both morale and operational cohesion. The strategic implications extended beyond immediate battles. Commanders of U.S. mechanized units recognized that sustained operational mobility, enabled by repair crews, allowed for faster advances and reduced vulnerability to counterattacks. Entire campaigns benefited. Cities and villages fell more quickly, supply lines were maintained, and tank brigades could be redeployed with minimal downtime. In effect, a small number of highly trained mechanics and support vehicles amplified the fighting capacity of entire divisions. As the first light of January 18th broke over the Ardennes, the battlefield told its own story. The U.S. armored columns continued their advance, largely unimpeded, while German forces reeled from a combination of terrain, attrition, and operational surprise. The silent labor of mobile repair crews, often unheralded in official histories, had reshaped the battlefield. Tanks that could have been counted as permanent losses remained instruments of war. Roads that seemed impassable became arteries of movement. Momentum, once threatened, was restored and preserved. The consequences of these operations were clear. The Americans had leveraged maintenance, repair, and logistics as decisive instruments of war. The Germans, despite skill, numbers, and tactical experience, had been confronted with a system capable of nullifying expected mechanical attrition. And as the soldiers moved forward into the next day of battle, the hidden yet critical power of the repair crews was undeniable. In the days following the Ardennes advance, the full impact of mobile repair crews became unmistakable. Commanders at corps and army levels observed a consistent pattern. American divisions were advancing faster, sustaining fewer permanent losses, and maintaining operational momentum far longer than German planners had anticipated. The capacity to restore vehicles under fire was no longer a localized advantage. It had become a strategic multiplier. Battlefield reports highlight that U.S. armored and mechanized units retained nearly 90% of their operational vehicles despite harsh winter conditions and continuous artillery pressure. German engineers, in contrast, were forced to abandon disabled tanks and vehicles far more frequently. Where a single broken Sherman could previously have represented a temporary setback, it was now swiftly returned to combat, amplifying the offensive power of entire battalions. This disparity forced German commanders to adjust defensive strategies, often ceding ground preemptively rather than risk being outflanked by a unit that could recover from mechanical failure faster than it could be destroyed. Morale was profoundly affected on both sides. American soldiers, witnessing tanks resurrected from mud and ice, gained confidence not only in the machines themselves, but in the competence and reliability of their support teams. The knowledge that mechanics could restore a vehicle to combat readiness under extreme conditions encouraged more aggressive maneuvers and fostered a sense of inevitability in their advance. For infantry units, this reassurance meant they could operate in closer coordination with armor, knowing that firepower would remain available even after a mechanical setback. German troops, however, experienced mounting frustration. After-action reports frequently noted astonishment at the Americans' ability to recover vehicles seemingly destroyed or immobilized by German fire. Field notes describe a growing perception that the U.S. Army was mechanically invincible within operational sectors where mobile repair units were active. Even elite panzer units, accustomed to controlling the battlefield through superior coordination and technical skill, found their efforts undermined by the efficiency of U.S. repair and recovery teams. The psychological toll manifested in cautious engagement, slower advances, and a reluctance to commit resources, contributing to incremental erosion of German operational effectiveness. Beyond morale, the efficiency of mobile repair crews directly influenced the strategic tempo of the Allied advance. Cities and supply nodes were captured more swiftly, armored divisions were redeployed rapidly across sectors, and offensive operations could be sustained with minimal interruption. Field reports indicated that units equipped with robust repair contingents could cover an additional 20 to 30 miles per week compared to formations lacking similar support, a difference that compounded across months of campaign operations. These gains did not come solely from firepower or manpower, but from the meticulous orchestration of logistics, repair, and redeployment, a principle that would shape future mechanized doctrines. Captured German records and post-war analyses confirm the long-term effects. Commanders consistently noted that the Americans' ability to maintain armored readiness reduced the effectiveness of German attritional tactics. Even when confronted with heavily mined roads, snow-clogged forests, and artillery barges, U.S. columns continued to move with minimal disruption. The cumulative effect of this operational superiority hastened the collapse of German defensive lines, contributed to the recapture of lost territory, and set the stage for the final Allied push into Germany. By the conclusion of January 1945, it was clear that mobile repair crews had done more than save vehicles. They had redefined operational capability. The war was increasingly shaped by the ability to sustain mechanized movement, not merely by tactical brilliance or numerical superiority. The silent labor of mechanics and engineers, operating in frozen fields, under artillery fire, and behind the chaos of battle, had shifted the balance, giving the Allies an advantage that German forces could not easily counter. In the Ardennes and beyond, these crews became unsung architects of victory. Their efficiency preserved lives, maintained offensive momentum, and provided a psychological edge that extended far beyond the battlefield. Tanks that might have been considered losses remained instruments of war. Supply lines that might have faltered remained intact. And as the Army pressed onward, the role of these mobile repair teams was recognized as a defining factor in the operational success of the Allied advance through Europe. The story of America's mobile repair crews is, at first glance, a story of tools, tracks, and engines. But it is ultimately a story of human ingenuity, determination, and the quiet power of preparation. In frozen forests and mud-choked fields, these men transformed breakdown into opportunity, delay into momentum, and obstacles into instruments of advantage. They were neither frontline heroes nor celebrated generals, yet their work shaped the pace and outcome of battles, turning maintenance into a weapon as decisive as any tank or artillery barrage. What the Germans witnessed and struggled to counter was a new form of warfare. Victory was no longer measured solely in guns fired or ground taken. It was measured in minutes saved, vehicles restored, and the relentless preservation of operational capability. A Sherman rising from the mud became a symbol not just of mechanical restoration, but of an army's capacity to endure, adapt, and advance against all odds. The battlefield had expanded beyond firepower and strategy to include foresight, skill, and the unyielding application of human effort under pressure. In the broader sweep of history, these repair crews exemplify the unseen forces that shape wars. For every tactical maneuver, there are countless hands ensuring that the tools of combat remain alive. For every breakthrough, there is a team working in silence to sustain momentum. Their legacy is not found in monuments or medals, but in the very principle that efficiency, innovation, and resilience can determine the fate of nations. As the Ardennes thawed and Allied columns pressed further into German territory, the lessons of these crews endured. Modern mechanized warfare would be forever defined by logistics and repair, by the realization that an army's strength lies as much in its ability to maintain itself as in its ability to strike. And in those frozen January fields, amidst the clatter of wrenches and the roar of restarted engines, a subtle truth was revealed. Sometimes the quietest efforts shape history most profoundly.